In this video, we're going to continue discussing the basic elements of C++. You've already seen how to declare variables and how to assign values to variables using assignment statements. In this video, we're going to cover the various arithmetic operators in C++, how to input values to a program and how to output values, which is called I/O, and how to comment your programs. So we're going to start with arithmetic expressions, and C++ supports all of the common arithmetic operations that you're familiar with. Please note that multiplication is using We're going to start with arithmetic expressions. And C++ supports all the arithmetic expressions that you're familiar with. Please note that multiplication uses an asterisk rather than an x, and that's because the C++ compiler is going to interpret an x as a variable name, not as multiplication. So please get used to using an asterisk to do multiplication. The other operation that you may not have seen before is the remainder operation, and it is only applicable to integer operands. So you're not allowed to use it with floating point numbers. And what the mod operator does is it returns the remainder when you do integer arithmetic. So for example, if I were to have 12 mod 5, the quotient is 2, because if you divide 12 by 5, it has 2, and it would have a remainder of 2. And so 12 mod 5 is equal to 2 because of the remainder. As another example, suppose that I were to have 27 mod 4. The answer to this is 3. The reason is the quotient is 6, right? Because 27 divided by 4 is 6 with a remainder of 3. So the mod operator, we call it mod. Sometimes you'll hear it referred to as mod. Sometimes you hear it referred to as remainder. Gives you the remainder. It works only with integer operands. It is an error if you try to use it with floating point numbers. And this operation comes in handy in a number of ways. For example, on the lab, where you are asked to find dollars and cents, you could have calculated the cents. If you had 243 cents, you could calculate that by modding it with 100. And the remainder is what cents would be. So you could actually have written something like cents equals number of cents mod 100. And that would give you the remainder is what would give you the number of cents. As another example, you use mod all the time with clocks. So there's 24 hours in a day, 1 a.m., 2 a.m., 10 a.m., 11 a.m. But at noon, 12, we start counting again, 1, 2, 3, 4, 5. So in fact, we are using the mod operation or the remainder operation with time, with the time being whatever, or the hours actually being equal to the total hours thus far in a day, mod 12. So if we're into the 14th hour of the day, that would be 14 mod 12, or we'd really be at 2 p.m. So mod or remainder operation is very helpful, and we'll see it several times in this course. The next thing we're going to talk about is mixed arithmetic. And we've already stressed the importance of looking at the two operands that are associated with an arithmetic operator when determining what type of arithmetic gets performed. There's two types of arithmetic that can be performed: integer arithmetic and floating point arithmetic. Floating or integer arithmetic is performed when both operands are ints. And floating point arithmetic gets performed when either operand is a double. Okay, so down here you see that the result of 4 divided by 5 is 0 because they're both integer operands, and therefore we do integer arithmetic. Whereas down here, because one of the two operands is a floating point number, the result is 0.8. So here's some examples that you could work through, but just quickly going through them, here we have mixed arithmetic, a floating point number divided by an integer, so we perform floating point division to get 4.1. In this example, we are doing integer arithmetic because both operands are integers, and therefore the result is 4. Now we get a little more complicated, and we're doing multiple operations, both division and multiplication. And you see the result is 6.0, and that may surprise you because you see that there is a 2.0 in this expression. But the reason we get 6.0 is because C++ is myopic when it does its arithmetic evaluations. So what's important here is the order in which the operations get evaluated, and multiplication and division, if you remember from your arithmetic classes, have higher priority than plus and minus, and they're evaluated left to right. So in this case, we're going to evaluate the division operation first, and C++ looks only at the two operands for that division. They're both integers, and so it does integer arithmetic, coming up with the value of 3. Now it multiplies 3 by 2.0 and performs floating point arithmetic because one of the two operands is a floating point number and comes up with 6.0. Notice that if we shift the order of the operations, the result changes. So now the first operation to be performed is 2.0 times 20, and because one of the operations is a floating point number, we get 40.0. And when we divide by 6, we have again a floating point operand, and therefore we get 6.667. So an important point here is that the order in which you present the operands matters. And because of mixed arithmetic, we can say that arithmetic expressions may not be commutative. So arithmetic expressions may not be commutative as they are in your regular math arithmetic. So that's an important thing to keep in mind. Here's a couple more examples. You have x and y declared as doubles, and our first operation is to assign the result of 20 divided by 6 to y. And again, you might expect that 3.333 would be assigned to y because that would be the result if we did floating point arithmetic on 20 divided by 6. But again, remember, C++ is very myopic. It evaluates the right-hand side expression first and ignores the left-hand side. So the operands to the division are both integers, so it does integer arithmetic, yielding the integer 3, which then gets converted to 3.0. So after this step, we have y is equal to 3.0. So 3.0 gets substituted in for the next statement. 3.0 times 5 is 15.0, and then 3.0 will get printed for y. So a reasonable question to ask is, if I have two integers, how can I force floating point arithmetic? And the answer is that you can multiply one of the two operands by 1.0 to force it to be a floating point number. So in this example, we have two integer variables, x and y, and we'd like to divide them, but we want to force floating point arithmetic. And you can see down here what I have done is I have forced y to become a, quote, a floating point number by multiplying it by 1.0. And now the outcome of that is a floating point number, so when I divide that into x, I'll get a floating point result. And the evaluation, you can see the order, because parenthesized expressions have the highest precedence for being evaluated. The parenthesized expression is evaluated first. It yields 6.0. So when I divide by 1 or it into 1, I get 0.1667. Note that if I had been careless and written it like this, the outcome would actually have been 0. And the reason is because without the parentheses, division and multiplication have equal precedence and they're evaluated left to right. So I would have first evaluated this expression, x divided by y, and since they were both integer operands, I would have done integer arithmetic, and 1 divided by 6 would have been 0. When I multiplied that by 1.0, I would have gotten 0.0. So when you force this kind of floating point operation, make sure you put it in parentheses. Next thing we're going to discuss is some shortcuts that you can perform in C++. So when you are doing texting, you're probably familiar with using abbreviations. Like you might say LOL for laughing out loud, or you might say CU instead of writing out the word CU. Well, just like you use some shorthand notation in texting, there's also shorthand notation for C++. So instead of having to, if we want to add a number to a variable and assign that value back into the variable, we could write it like this, n equals n plus 2. But C++ allows us to write some shorthand. We could also just say n plus equal 2, and that tells C++ to add 2 to n, assign the value back to n. Similarly, n times equal 1 says multiply n by 1 and assign the result back to n. And these operators also exist for minus, division, and the remainder operation. And just a word of caution, if you use them, it is assumed that whatever appears in this expression is parenthesized. So when I write x times equals 3 plus 5 here, that is interpreted as x equals x times 3 plus 5. So make sure that when you specify this expression, you remember it's as though it's been parenthesized. You can also use even further shorthand, which is the plus plus and minus minus operators. Plus plus increments or adds 1 to a variable and assigns the result back. So if I say x plus plus, it's equivalent to adding 1 to x and then assigning the result back to x. So for example, if I said x equals 5 and then I said x plus plus, the result would be that at the end of these two operations, x would have the value 6. Similarly, down here with x minus minus, if I said x equals 10, and then I say x minus minus, the end result is x has the value 9. It is okay to write it either this way, or to write it as x plus plus, or to say x plus equals 1. All of them are equivalent. You'll just see these shortcuts frequently used. Another shortcut is you'll sometimes see the same value assigned to multiple variables like this. So we're setting x, y, and z equal to 0. And in this special case, it's right to left execution, meaning first the operation is applied to z, the outcome is assigned to y, and that is assigned to x. But basically, the idea is you can assign the same value to multiple variables in the following way. Okay, that takes care of arithmetic expressions, and we're going to move on to input and output. And you've essentially seen how to do input and output. You use cin for getting input from the user, and you use cout to get output or to produce output to the user on the terminal. In C++, first of all, I/O means input and output, so it's shorthand for input and output. And we say that in C++ that input is a stream of characters. And the reason we say that is because new lines are actually ignored in the input. You might type a list of animal names in this order, each on a separate line. But when you input that to C++, what it sees is a single line of 4 names. Hence, we say it's just a stream of characters. Like in a stream, in a real creek, you have water running in a stream. In a linear fashion, it's the same way with C's input. So we're first going to talk about output, and cout stands for console out, okay, which the console is just another name for your terminal window. And remember that cout uses the less than operator, and you use the less than operator to separate your operands. So here I'm printing out the string sense equal, and I'm printing out the value of the variable sense. And you haven't seen this one before, but \n means print a new line character. It's the same as putting end L right here. Okay, so you can think of the less than as a delimiter that separates different parts of the cout statement. And it's the same as like punctuation, the comma, in a sentence. So it helps separate things for the C++ compiler. Another important thing is that cout does not put blank spaces between your strings or variables. So in order to get a space here between, if I run this statement right here, and let's say that the sense has the value 5, and this is going to print out sense, and this is a space right here, equals, and I put another space there, and then it's going to print out 5. If I forget to put a space right here, then you would see the 5 jammed up against the equal sign. So if I had said cout sense, and you see equal, and I'd forgotten to put a blank space, and then sense, and then the \n, what you would see for the output would be sense equals, and the 5 would be jammed right up against the equal sign. So, bottom line, you have to make sure that you put spaces in explicitly. And please don't get confused by what I've done here. I'm just using that character to show that there is a space there. That little underscore doesn't show up on your actual output. It would be a blank space. And I just told you that \n, in quotes, is comparable to using end L. And either of them will create a new line. \n is called an escape sequence because if I just used n, it would literally print out n, but by putting \n, it says this is a new line character. And there's a few such escape sequences. So \n means a new line. \t will put a tab in your output. if you really need to put a backslash in your output, you would have to put \\\/ in order for a single backslash to appear. And if you wanted to put a quote in your output, you would need to put \quote. So for example, if I had wanted to output Mary said, "Hi there," you might be tempted to write cout, Mary said, "Hi there." Okay, but what would happen is the compiler would say, oh, I'm going to print out Mary said, and then I see the quote, and now you're going to get an error message from the compiler because it's going to try to say that hi is a variable because it's outside the quote. So in order to make this work the way you think it should, what you have to do is you have to put a backslash in front of this quote and a backslash in front of that quote, and now it says literally print out a quote in the output stream. You may also wonder, when should I use \n and when should I use endl? And the bottom line is, I really don't care. If you want a slightly more definitive answer, it is common to use endl if your output is terminated by the contents of a variable like it is here. Whereas if your output is terminated by a string, so let's say I had said cout is simply less than hi Brad, typically now I would put the \n there because my output is terminated by a string. But that's a fairly loose rule. You're free to use whichever you feel comfortable with. And you often are going to want to be able to control the number of decimal places that print out after a dot. So if I were to just say cout, say 5.0 divided by 3, you might well get something like 1.6667. But let's say I only wanted to print 2 digits of precision. What I really want to see is 1.67. The way I can do that is using what we call for the time being the magic formula, which is you first do cout.setIf iOS fixed. And what that's saying is we want to show our numbers using a fixed format rather than scientific notation. Scientific notation is the default notation. So if I have a very large number, say 1357892.1.1235, it turns out that there's a limit to the number of digits that can be stored in a C++ variable. Say this was weight. And therefore, when it prints out, what you're going to see is what's called scientific notation. You might say 1.35789 exponent, and this is really 13,578,921. So you might see it as exponent plus 07. So this is the default output for C++. It's called scientific notation if you've never seen it before. Okay, and the reason it says exponent plus 07 is it means 1.35789 times 10 to the 7th power, which you can't write it this way in a program, but mathematically that's what it means. And you've actually lost this precision right here because it can't store that many digits perhaps. So that's the way numbers would normally print out if they were large in C++. By saying that we want it to print out as iOS : fixed, it's going to print it out in a standard decimal format that we're accustomed to seeing. Show point just put that in there for the time being. It forces a decimal point in certain circumstances. And finally, the precision 2 is important because it tells us how many digits we want to output. In this case, we want 2 digits after the decimal point. So whenever you're trying to control the number of digits that appear after the decimal point, use these 3 statements exactly as shown, except with the 2 replaced with however many digits of precision that you want. In CN, you have seen so far for reading input. It stands for console in, and it takes input from the terminal or from the terminal window, and it uses greater than as its delimiter. And you can see that we use greater than to separate our list of variables. So variables are separated by the greater than, and the reason it goes greater than is to give the idea of input going from the console to these variables. And it's okay to write your input either this way or this way. This second way often improves the readability. It's easier for a reader glancing at your program to see that we're reading a list of 3 variables. But either way is fine. This is just program style. The last thing we're going to talk about is comments. And a comment is a note that explains part of your code. It is discarded by the compiler when it compiles your code to machine language or to object code. But comments are important both for the people who maintain your code, for the teaching assistants who look at your code, and also for yourself if you come back to the code months later. And there's a number of places that you typically use comments. So first of all, there's normally a block of comments at the top of your program giving an overview. It's like an introduction to a paper or an abstract. You also can use it to explain what's being accomplished by a block of statements. And it's often used as part of a variable declaration to tell us what the variable does. Now, if you use meaningful variable names, which we strongly encourage you to do, you don't always need a comment because often the variable name itself is descriptive. There's 2 ways to write comments in C++. You can start a line with // and then everything that follows the // is a comment. Or at the end of the line, you can put //. We call that an inline comment because it's on the same line as the statement it's describing. If you want to use a multi-line comment, it's more common to embed the comment in a /* and terminate it with an */. And when you do that, you'll notice that the second line did not start with a /*. So it just saves you a little bit of typing. So multi-line comments you often see enclosed in the /* and the *//. Single line comments you often see as //. And one important thing is you cannot embed comments. So here I'm trying to embed one comment inside the second comment. This would cause the compiler to complain. Now, writing comments is more of an art than it is a science. So we'll give you some general guidelines, but you'll have to kind of also gain experience. Remember I said it was a good idea at the start of the program to have a block of comments describing what it does. Since it's multiple lines, I've used the ** format. And actually, it's just this part and this part that's starting and terminating the comment. This part right here just makes it look prettier, and this part right here just makes it look prettier. They're not really part of it. So we encourage you right now to kind of identify the problem. This is an old notation. Probably now you'd say assignment 1, maybe part A, or you might say assignment 1, A1 for part A. And then written by you as the author. If anyone helped you, we ask you to put their name down, although you don't have to do it if it's a TA or one of the instructors. Be sure that if someone helps you, they do not write your code, that you write the code yourself. They're only allowed to discuss general ideas with you. And finally, just a very short comment that describes the program. So here we're saying ask the user to input the number of quarters, dimes, and nickels in their pocket, and outputs the monetary value of the coins and cents. So we don't want a long-winded novel here. We want a short, pithy description of what the program does. And we want you to have comments, but too many comments can smother a program. And the guidelines we have is you don't want to comment each statement, and you don't want to use comments to explain obvious code. So for example, this is a bad comment. Just someone looking at your code knows that you're adding 1 to count. There's no reason to say increment count. By increment, we mean add 1 to it. So we often say use comments to describe a block of statements. So here we are prompting the user for quarters, nickels, and dimes, and it's 2 statements that we are commenting. In the labs, one useful place for comments is to separate your Part A and your Part B code. Typically, your Part B code is going to sequentially follow your Part A code, and therefore you could have a comment for your Part A calculations, separate comment for your Part B calculations. Now in Lab 1, Part B is actually changing Part A, but that will not normally be the case. Normally, you will keep your Part A code and Part B will add to it. Another good place for comments, you'll remember that I said that when you write a program, it's a lot like writing a composition. You kind of organize your program into sections. So initially we have an input section, a processing section, and an output section. So you might put comments at the start of each one saying what you're doing, that this is collecting input, or this is doing the processing, or this is doing the output. You may remember we also talked about the concept of within sections you might have so-called paragraphs or groups of statements doing a related task. Like back here, the related task was a cout and a cin that collectively were getting some input from the user. So you might also consider, if you have a quote paragraph or set of statements doing a related task, you might just comment that related task. Again, you will get better at writing comments as the semester progresses.